Okay. Okay, dah start.
Okey. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Nama saya Muhammad Hafizuddin Berosli, bersama grup member saya Muhammad Amir Najib bin Muhammad Hussein. Kami nak buat perbentangan untuk problem based task PBT. Next please. Okay. Instruction in this PBT, you are required to perform 3 tasks. The tasks are: first, configure static route and static default route. Dua, configure hot standby redundancy protocol HSRP. Yang ketiga, configure dynamic host configuration protocol DHCP. This task will access CL01, which is manipulate router configuration with advanced feature to support end-to-end connectivity in router network configuration. You will also need to record the process of network building and all the configuration along with explanation for each step. You will access CL02, which is demonstrate leadership, autonomy, and responsibility while solve common configuration issue in complex network. All tasks must be done in group and each group must consist of 3 to 4 people. Next. Task 1. Configure IPv4 and IPv6 static and default route. In this task, you will configure static, default, and floating static route for both and IPv4 and IPv6 protocol. Configure IPv4 static and floating static default route. Configure IPv6 static and floating static default route. Configure IPv4 static and floating static route to internal LAN. Configure IPv6 static and floating static route to the internal LAN. Configure IPv4 host route. Configure IPv6 host route. Next. Okay. Configure IPv4 static and floating static default route. The PT network requires static route to provide internet access to internal LAN user through the ISPs. In addition, the ISP router requires static route to reach the internal LAN. In this part of the activity, you will configure an IPv4 static default route and a floating default route to add redundancy to the network. Yang pertama, configure an IPv4 static default route. On edge router, configure a directly connected IPv4 default static route. This primary default route should be through router ISP1. Dia boleh configure IP route 0000 10 10 10 and 1. On edge router, configure a directly connected IPv4 floating static default route. This default route should be through router ISP2. It should have an administrative distance of 5. Dia punya configure IP route 000000101010.10.5.5. Yang kedua, configure IPv6 static and floating static default route. In this part of the activity, you will configure IPv6 static default and floating static default route for IPv6. Yang ketiga, configure an IPv6 static default route. On edge router, configure a next hop static default route. This primary default route should be through router ISP1. Dekat edge router, command dia IPv6 route /02001 TB8A11. Yang keempat, configure an IPv6 floating static default route. On edge router, configure a next hop IPv6 floating static default route. The route should be via router ISP2. Use an administrative distance of 5. Dekat edge router, IPv6 route /02001 DB8A215. Configure IPv4 static and floating static route to the internal LAN. In this part of the lab, you will configure static and floating static router from the ISP router in the internal LAN. Pertama, configure IPv4 static route to the internal LAN. On ISP1, configure next hop IPv4 static route to the LAN 1 network through edge router. Dekat ISP1, IP route 192.168.10.16. 255.255.255.240 10.10.10.2. B on ISP1, configure next hop IPv4 static route to the LAN 2 network through edge router. Dekat ISP1, IP route 192.168.11.32. 255.255.255.254 10.10.10.2. Yang kedua, configure IPv4 floating static route to the internal LAN. A on ISP1, configure directly connected floating static route to LAN 1 through the ISP2 router. Use an administrative distance of 5. Dekat ISP1, IP route 192.168.10.16. 255.255.255.240 G0/0 5. Lepas B on ISP1, configure and directly connected floating static route to LAN 2 through the ISP2 router. Use an administrative distance of 5. ISP1, IP route 192.168.1.11.32. 255.255.255.254 G0/0.5. Configure IPv6 static and floating static route to the internal LAN. First, configure IPv6 static route to the internal LAN. On ISP1, configure a next hop IPv6 static route to the LAN 1 network through edge router. Dekat ISP1, IPv6 route 2001 DB8 110/64 2001 DB8 A12. On ISP1, configure a next hop IPv6 static route to the LAN 2 network through edge router. Dekat ISP1, IPv6 route 2001 DB8 111/64 2001 DB8 A12. Lepas tu yang kedua, configure IPv6 floating static route to the internal LAN. On ISP1, configure a next hop IPv6 floating static route to the LAN 1 through the ISP2 router. Use an administrative distance of 5. ISP1, IPv6 route 2001 DB8 110/64 2001 DB8 FF25. On ISP1, configure next hop IPv6 floating static route to LAN 2 through the ISP2 router. Use an administrative distance of 5. ISP1, IPv6 route 2001 DB8 111/64 2001 DB8 FF25. If your configuration has been completed correctly, you should be able to ping the web server from the host on LAN 1 and LAN 2. In addition, in the primary route link is down, the connectivity between the LAN host and the web server should still exist. Configure host route. User on the corporate network frequently access the server that owned by important customer. In this part of the activity, you will configure static host route to the server. One route will be a floating static route to support the redundancy of ISP connection. Oh. Yang pertama, configure IPv4 host root. In Edge router, configure an IPv4 directly connected host root to the customer server. Edge router, IP root 198.0.10.10.255.255.255.255, serial 0/0/0. On Edge router, configure an IPv4 directly connected floating host root to the customer server. Use an administrative distance of 5. Edge router IP root 198.0.10.25.255.255.255.255 serial 0/0/15. Yang kedua, configure IPv6 host route. On Edge router, configure IPv6 next host route to the customer server through the ISP1 router. Edge router, IPv6 route 2001 DB8 FF10/128 2001 DB8 A11. On Edge router, configure IPv6 directly connected to the floating host route to the customer server through the IPv2 router. Use an administrative distance of 5. Edge router, IPv6 route 2001 DB8 FF10/128 2001 DB8 A215. Seterusnya saya serang kepada Nabil.
Okay. Seterusnya saya Muhammad Hussein menggunakan untuk task 2 configuration for standby redundancy protocol HSRP. So in this task, our group will configure HSRP on router R1 and R3, which serve as the default gateway for the host on LAN 1, LAN 2, and LAN 2. And when we configure HSRP, we will create a virtual gateway that uses the same default gateway address for hosts in both LAN. If one gateway router becomes unavailable, the second router will take over using the same default gateway address that was used by the first router. Because the hosts on the LANs are configured with the IP address of virtual gateway as the default gateway, the host will regain connectivity to remote network with HSRP active, which remain router. So this is our network topology that we will use. There are 2 PC, 2 switch, 3 router and web server. This is our addressing table and the IP address to be used in our configuration. So for verified configuration, first change the path to the web server from PCA. Go to the scope of PCA and open command prompt. Trace the path from PCA to web server by execute the trace 209.165.200.226 command. So in our PCA command prompt, we will use it the command trace 209.165.200.226 and when the tracing route to 209.165.200.226 and this the output we got. So the question is which device are on the path from PCA to the web server. Use the address table to determine the device name. So in here we got R1, R2 and iNet. For the second, trace the path to the web server from PCB. Repeat the process in step 1 from PCB. So we just repeat from PCB command prompt and the device on the path from PCB to web server is same R1, R2 and iNet. So the step is observe the next behavior when R3 become unavailable. Select the delete tool from packet tracer toolbar and delete the link between R3 and S3. Open command prompt on PCB, execute the trace command which the execute the trace command with the web server as the destination. So when we already delete the connection between R3 and F3, our current input is different between step 1 and the step 3. So what is the result? PCB can communicate with the R2 and INET. So after that we click the connection icon in the lower left corner of the PT window and look at this and select the copper thread through icon in the palette of connection type. Click on S3 and select port Gigaether 02. Click on R3 and select port Gigabit Ethernet 00. After the link light on the connection are both green, that's the connection by pinging the web server, the ping should be successful. So here we will use the password 20.165.200.226 and the test will be the output is right here, as you can see. After that, configure HSRP active and standby router on R1. Configure HSRP on the G01 LAN interface on R1. Specify the HSRP protocol version number. The most recent version is version 2. Configure the IP address of the virtual default gateway. This address must be configured on any host that require the service of the default gateway. It replaces the physical interface address of the router that require the service of the default gateway. It replaces the physical interface address of the router that has been previously configured on the host. Multiple instances of HSRP can be configured on router. Designer and the active for the HSRP in the group. It is the router that will be used as the gateway device unless it's failed or the path to it become inactive or unstable. Specify the priority for the router interface. The default value is 100. A higher value will determine which router is the active router. If the priority of the router is in the HSRP group are the same, then the router with the higher configured IP address will become active router. R1 will operate as the active router and traffic from to LAN will use it as the default gateway. If it is disabled, that the active router resume that role when it become available again. Configure it to prime the service of the standby router. The active router will take over the gateway role when it become operated again. So in router 1, we can interface to Giga Ethernet 01 and standby version 2. So that we use standby 1 IP 192.168.1.1.254. After that, the state becomes standby and become active. Then we can standby 1 priority 150 and standby 1 from. So what will the SRP priority of R3 will be when it added to HR group 1? So the HSRP will be 100, which is the default value. So we will configure HSRP on R3. Configure RS as the standby router. Configure the R3 interface that is connected to LAN 2. Repeat on this step 1 and 1B and 1C above. So at router 3, we will configure Giga Ethernet 00. standby version 2 and standby IP, standby 1 IP 192.168.1.254. Next step is verify HSRP configuration. Verify HSRP by issuing the show standby comment on R1 and R3. Verify the value for HSRP role, group virtual, IP address of the gateway. Permission and priority note that HSRP also identify the active and standby router IP address for the group. So here in R1 we use command show standby, and here we can see the state is active and the virtual IP is 192.168.1.254 and permission is enabled. The active router is local and standby router is 192.168.1.3 and priority is 100. And for the router R3, we use the same command, that is show standby. And here we can see the state is standby and virtual IP address is 192.168.1.254 and permission is disabled. The active router is 192.168.1.1. The standby router is local, priority is 100. So using the output, answer the following question. Which router is the active router? So if we see here, the router is active is R1. What is the MAC address for virtual IP address? When we see the, here we can see the MAC address is 0000.0C9F and F001. What is the IP address that and the priority of the standby router? The IP address is 192.168.1.3 and the priority is 100. Use the show standby brief command on R1 and R3 to view and HSRP status summary. So and at R1 we use show standby brief. It will show the standby brief result here. So at Giga 1, group 1, the priority is 100, state is active local, and standby is 192.168.1.3 and virtual ID is 192.168.1.254. For the R3, we use the show standby brief also. The interface is Giga Ethernet 00, group 1, priority 100, state standby, active 192.168.1.1 and standby local, virtual IP is 192.168.1.254. After that, we change the default gateway address for PCA, PCB, and S1 and S3. The address that we use is 192.168.1.254. So yeah, that we change the IP default gateway at switch 1 and switch 3. And here is change the default gateway at 192 at PCA. And here we change the default gateway at PCB. Verify the new setting issue a ping from both PCA and PCB to the web server. Are the pings successfully? Yes. When we ping from PCA, the web server can cache our ping, and from the PCB, also the ping is successfully. Next is observe the HSRP operation. Make the active router become unavailable. Open the command prompt on PCB and enter the command trace 209.165.200.226. And here we can see the result of trace. The patch different from the patch used from HSRP was configured. So our answer is no, because it's still using the same route. After that, break the link to R1. Select the delete tool from packet tracer toolbar and delete the cable that connect R1 to S1. After that, we go to the PCB and trace 209.165.200.226 command again, and also the output. As you can see, the output here is different for the 192.168.1.3 because it use the router root at router 3 and S3. So how was this trace different from the previous trace? Because R3 used as the first top gateway in this trace instead of the R1. SSRP undergoes a process to determine which road should take over when the active road become active and become unavailable. This process takes time. Once the process is complete, the R3 standby router become active and it is used as the default gateway for host on LAN 1 and LAN 2. So starting we will restore the link to R1, reconnect the R1 and S1 which copies the through cable, and then we will go to the PCB command prompt and trace web server. So here we show the result. The trace is using the 192.168.1.11 again. So what patch is used to reach the web server? The patch used is R1. If the prem command was not configured for the HSRP group on R1, would the result be same? No, because the R3 would not become the gateway. So for the task 3, configuration dynamic host configuration protocol, DHCP v4. In this task, you will configure a Cisco router as DHCP server. You are also required to configure the S router as a DHCP client so that it receives an IP address from ISP network. So this is our network topology. We have 3 router here and 3 switch. To web server, there is www.cisco.com and www.publicsite.com. We also have 2 PCs and 1 DNS server. This is our address table. Next is configure a router as DHCP server. First, configure the exclude IPv4 addresses. Address that must be statically assigned to device in the network that will use DHCP must be excluded from the DHCP pool. This avoid error associated with the application IP address. In this case, the IP address of the R1 and R3 line interface must be excluded from DHCP. In addition, none other addresses are excluded for static assignment to other devices such as servers and device management interface. So configure R2 to exclude the first 10 addresses from R1 LAN. So at the R2 we use IP exclude address 192.168.10.1, 192.168.10.10. Also we use IP DHCP exclude address 192.168.30.1 and 192.168.30.10 untuk R3 LAN. Next is create a DHCP pool on R2 for the R1 LAN. Create a DHCP pool name R1 LAN. So at R2 we use IP DHCP pool R1 LAN. Configure DHCP pool to include the network address, the default gateway, and the IP address of the DNS server. At R2 we use network 192.168.10.10 and default gate and subnet mask 225.225.225.0 and default router is 192.168.10.1 and the DNS server 192.168.20.254. For step 3, we will create a DHCP pool on R2 for the R3 LAN. Here we use IP DHCP pool R3.LAN and then we use network 192.168.30.0 and 255.255.255.0 And this default router is 192.168.30.1. And the NS server is 102.168.20.254. After that, we configure DHCP relay. First step is configure R1 and R3 as a DHCP relay agent. For the DHCP client to obtain an address from server on a different LAN segment, the interface that the client are attached to must include a helper address point to DHCP server. In this case, the host on the LAN attached to R1 and R3 will access the DHCP server that is configured on R2. The IP address of the R2 serial interface that are attached to R1 and R3 are used as the helper address. DHCP traffic for hosts from the host on the R1 and R3 LAN will be forwarded to these addresses and processed by DHCP server that is configured on R2. So configure the helper address for the LAN interface on R1. First we in the R1 and interface Giga Ethernet 00 and IP help address is 10.1.1.2. Next we enter the R3 and enter Giga Ethernet 00 and use IP help address 10.2.2.2. So next is configure host to receive IP address information from DHCP. Configure host PC1 and PC2 to receive their IP address from DHCP server. Verify that the host have received their addresses from the correct DHCP pool. So there we here you can see the default. The DNS server is 192. The DNS server request is successful at PC1 and PC2. Next is configure a router as a DHCP client. Just as a PC is able to receive a IPv4 address from server, a router interface has the ability to do the same. Router R2 need to be configured to receive addressing from the ISP. Configure the Giga Ethernet 01 interface on R2 to receive IP address from the DHCP and active the interface. So we enter the R2 and interface Giga Ethernet 01, IP address DHCP, and now shut down. Use the show IP interface brief command to verify that the R2 received an IP address from DHCP. So at R2 we use show IP interface brief. So here we can see the interface IP address. The Giga Internet 01 is 192.168.20.21 and Giga Internet 01 209.165.200.223.1 and the method is DHCP. The serial 000 is 10.1.1.2 and serial 001 10.2.2.2. Next is verify DHCP and connectivity. Step 1, verify DHCP binding. So at R to show IP DHCP binding, as you can see the IP address is, you can see the DHCP binding here 192.168.10.11 and the type is automatic, and 192.168.30.11 also the type is automatic. Second is verify configuration. Verify that PC1 and PC2 can now ping each other and all other devices. So at PC1, we will enter the command prompt and try to ping to which the IP address 192.168.30.1 and the ping is successfully. And also we can try to the another ping 192.168.20.254. Also the ping is successfully. That means it can connect to all devices. At the PC2, we will ping at 192.168.10.11. As you can see here, the ping is successfully. we can also try ping the another IP address. Here we use 192.168.20.24 and we can see here the ping is also success. That's all from our team. Thank you.